We want to look here at arcs and sectors, which are very, very closely linked to circles. And we'll have seen the area and circumference of a circle before. But if we cut a bit of pie out, or a bit of pizza out of a circle using a radius and a radius, then what we can do is, let's colour that in so it's yellow. Then what we end up with are two sectors. So a sector, this is what we call the minor sector, it's the smaller sector, and this is the major sector, it's the bigger bit. But that's been that's been found just by two radii, and then that bit of pie or that bit of pizza is cut out of the circle. And around the outside, now in a circle, we have a circumference of a circle going the whole way around. But when we talk about part of a sector, then we talk about the arc of the sector. So this would be the minor arc because it's the smaller arc, and then for this part, this would be the major arc, the bigger bit. Now what we're normally asked to do with circles is either find the area of the whole circle or find the circumference of the circle. And actually we can use those two facts that find how to find the area and circumference of a circle to help us find the area of a sector and the arc length of a sector. Because really this is just a fraction of the whole circle. And so sometimes we let the little angle in the middle there stand for theta. It's a Greek letter, theta. Now, if I know that angle is say 90 degrees, well, if that angle is 90 degrees, then this must be 1/4 of the circle because I know that it's 90 out of 360. And so if I want to find the arc length of this sector, what I would do is I would find 1/4 of the whole circle's circumference. And we can do that for any arc. So for any arc length that we want to find, L is equal to, well, the fraction of the circumference of the whole circle. So we can imagine there's a whole circle there, what fraction of it are we talking about? And so in this case, that's, well, whatever angle theta is divided by 360. That's the fraction of the circle. In maths, of means multiply, and the circumference, well, we know that the formula for the circumference of a circle is just pi d, or 2 pi r. So the arc length of any sector is theta over 360 multiplied by pi d. But actually, it's maybe easier just to remember that it's a fraction of the circumference of the whole circle. How do we get the fraction? Well, it's theta out of 360. In the same way, if we want to find the sector area, well, the sector area A it's a fraction of the circle's area. So in this case, the area of a sector is, well, what fraction of the whole circle is that sector? Well, it's theta out of 360, whatever that might be. Of means multiply, and we know that the circle's area is pi r squared. And so the formula for the area of a sector is just a fraction of the circle's area. So it's theta over 360 times pi r squared. So let's look at a couple of examples here. First of all, find the length of the minor arc of these sectors. Now, this is the minor sector. So the minor arc, the smaller arc, is going to be this little bit here. So I'm just going to call it L. Okay, it's going from there round to there. And now I know L is equal to a fraction. Well, what fraction is it? Whatever angle is at the middle of that sector, divided by 360. That's the fraction of the circle, theta over 360. And we're multiplying that by pi times the diameter. This is the fraction of the circle we're talking about multiplied by the circumference, a fraction of the circumference. So let's fill that in now and see what happens. So L is equal to, well, in this case, our angle is 55 degrees out of a total of 360. And we're multiplying that by pi times, and in this case, you can see hopefully the radius of this circle would be 8 centimeters. So if I want to find the diameter, I times it by 2, so it's 16. And we can put that into our calculator then. And when we do that, we get 7.68. And because that's a length, it's an arc length, it's the same units as the radius, so centimeters. What about this bottom one? Well, here's the minor arc, the smaller of the two arcs. And what I want to do is find this arc length here. I know the angle at the center of the circle, or sorry, the center of this sector is 100 degrees. So let's find the arc length L. So here's L, all the way from here round to here. The arc length is whatever fraction of the circle we're talking about multiplied by the circumference of the circle. It's a fraction of the circumference. So let's fill in everything we know. The angle is 100 out of 360 degrees. Okay, there's our angle. It's 100 out of a total of 360 degrees. And now we multiply that by pi, and we multiply it by the diameter. Now again, we know here the radius is 20 meters, so the diameter is going to be 40 meters. And again, we can plug that into our calculator. And when we do, we get 34.9. And again, we're talking about a length, an arc length. So this will be the same units as the radius. And the radius is in meters, so it's 34.9 meters. Likewise, if we want to find the shaded area of a circle, now again, I know that the area of a circle is a fraction, or sorry, the area of a sector is a fraction, theta over 360, times the area of the circle, so pi r squared. Now in this one here, hopefully you can imagine, if this was a full circle, go right the way around here, okay, like that. You can see that the radius of that circle would be 13 meters. So I just need to fill that in. So it's times pi times 13 squared. The angle at the center of this sector is 82 degrees, and we're dividing that by 360. And it's great because we can just put that into our calculator exactly like that. And when we do, we get 120.9. Now again, this is an area, so our units, instead of being meters, are going to be meters squared. This final example, we're asked to find the shaded area. So what is this blue area here? Actually, I know this is 60 degrees. But we just need to be a little bit careful. If we know that that's 60 degrees, sorry, I should have said that O stands for the center of a circle, then that angle must be 300 degrees. And so filling this in, area is a fraction of the area of a circle. So the area of our sector is, in this case, it's 300 over 360 multiplied by pi times the radius squared. In this case, the radius is 17. And when we plug that into our calculators, we get 756.6. And again, we're talking area here, so it's centimeters squared as our units. So every time we do this, and we're working with a sector is a bit of pie, a bit of pizza. Okay, it's like a slice being cut out of a pizza. We find out what fraction of the circle we're talking about. So theta over 360, whatever angle is divided by 360. Whatever angle this is divided by 360. And then if we want to find the area of these sectors, we multiply that fraction by the area of the whole circle if it was there. The area of the whole circle. And if we want to find the arc length, then we multiply this fraction by the circumference of the full circle if it was there.